Okay, good afternoon everyone. Welcome to the NodeRED workshops. My name is Pete Wood, I work for RS Components. We've sponsored the Raspberry Pis and things here today. So I'd just like to say a few thanks, I guess, first of all to the BCS Open Source Group and the Knowledge Transfer Network and OSHUG and the Fab Lab. The guys from IBM here with us today for helping out, Dr. Lisa Rogers as well. Who have I missed? I don't think I missed anybody. So thanks to all of those guys for making this possible. Hopefully we'll have a great afternoon. We're going to kick off with Dr. Lisa Rogers, who's going to talk a little bit about some of the things she's done with IoT-based projects, and then Andy's going to come on and sort of do the introduction to the start of the workshop, and then we'll get into the practical. So we've got badges at the back, so I guess when we sort of break around, go and get some coffees and stuff, if you can find yours and stick it on, that would be most useful. We are going to be filming today. If there's anybody in the room who does not want to appear on camera, please say now, we'll avoid you. That's the right answer, fantastic. It's literally just to put up, there's going to be two videos, one for the OSHUG website, which is basically the talks this afternoon, sorry, and we're going to be filming for RS Components as well, so we're literally just going to put a video together of you guys tinkering with things, and we get some shots of these guys later, so just to show you guys, you know, in engineering excellence, if you like. So that's it. So without further ado, I'll kick off with Dr. Lisa Rogers. She's going to talk a little about some of the cool stuff she's done with IoT and this and that. So, thank you.
Mainly this and
that. Yeah.
Hi, I'm a mechanical engineer by training, and so anything electrical was always a bit on the black magic side, and anything computer programming was also on the black magic side, until I discovered NodeRED. And that brought me to being able to actually hack stuff. So much so that a theme park on the Isle of Wight, Black Gang Chine, asked me to come and hack their dinosaurs. They have big, full-size animatronic dinosaurs. The electronics that were in them were sometimes not doing quite what the staff wanted them to do. So they were roaring and then opening their mouths, wagging their tails when maybe they should all be still. Things that wanted changing. So I was invited down to come and hack the dinosaurs. I arranged a workshop called Black Gang Pi, and we had a little prototype, my little prototype, because when you can't actually have the real dinosaur on your desk when it's so big, you need a little thing. So I've got LEDs that light up when I click on various things. We've also got a little toy dinosaur over here, if you want to just press my eject there. He nods as well. So we were using little interactive toys. Thanks. To make it more fun. We invited a load of people down, including Andy, who showed us how to use the NodeRED. Now all the staff at Black Gang can program their own dinosaurs. So we put a Raspberry Pi inside the control box of the dinosaurs, and we can program them to do what we want. So amongst other things, that's what I've been playing with, hacking dinosaurs. Andy?
Great, thanks Lucy. So, yeah, the Raspberry Pi, Black Gang Chine stuff was very exciting. I got one of these dinosaurs as well. I should point out that my daughter bought me this for Christmas because she thought I was into dinosaurs. They're probably cool. It's a £10 kit you can get from Maplin. Within half an hour, like on Christmas morning, having built it, I realised there was a big space underneath. You can't let these spaces go to waste, so it's now got a, it's got a Raspberry Pi inside there. And a speaker, and the Raspberry Pi runs the NodeRED software, which we'll be talking about in a moment. But now, this one listens out for tweets about me. So if anybody tweets me during this thing, this will roar. I'm at NDSC. Okay, so my name's Andy Stanford-Clark. I'm one of IBM's distinguished engineers, which means I'm sort of one of the senior technical people. I'm also one of IBM's master inventors, which means I've got lots of patents. I've actually got 43, going back quite a long time. I've actually been playing around with Internet of Things for much longer than the term Internet of Things has been around. It's been called lots of different things along the way. Pervasive computing, ubiquitous computing, machine to machine, smarter planet, SCADA, a whole bunch of things. But it's actually what we're now calling Internet of Things, so it's kind of the same stuff. I started in this area 17 years ago, in fact, and I've been doing quite a lot of cool stuff ever since. Initially in oil and gas pipeline networks with oil companies, then suddenly realised the technology we were creating, we moved in. Okay, just hold that thought, 246. I'll explain why I was doing that in a moment. And then we moved into other sectors like transport, agriculture, cows in and out of milking parlours. I've wired up the Isle of Wight ferries so they tweet whenever they leave and arrive at ferry ports, which is really useful if you're a commuter, like I am, to live in the Isle of Wight. And everywhere I go, I'm looking for IoT problems to solve. That's really exciting. And I don't know, 2 years ago, we crossed a tipping point between having to be an electronics wizard and be able to create these things yourself using soldering iron and assemble things yourself, to things like the Raspberry Pi and the Arduino and off-the-shelf sensors and places in the internet where you can send data very easily to sort of park your applications, things like IBM's Bluemix and our internet connection service, which enable you to very easily write applications and deploy them to do cool IoT things. And the NodeRED software, which we're going to be talking about this afternoon, makes it really, really easy if you're not a heavy-duty software engineer, like I am. You have to worry about semicolons and closed braces and all those nasty things that normally stop programs working. For quite a lot of simple just wiring an input to an output and doing something with the data, you can do it without any actual programming. A lovely example was that one of Lucy's friends in London said, oh, wouldn't it be cool if when the bus was 10 minutes away from my bus stop, it could flash a little light on my mantelpiece and I could just grab my bag and walk out and catch the bus. So a couple of tweets later, and Lucy's writing this application which uses the TfL API to their open data sources for where all the buses are, and that was being queried every few seconds to see when there was a bus 2 stops away. Then it delayed for a few minutes to let the bus get a bit further up the road, and then it triggered an LED light flashing to say the bus is coming. And that was probably half an hour's work or something like that. And it's now deployed and in production, and this friend is very, very grateful for the fact that she can now find out when the buses are coming. That's a really nice example of the fact that if you just things you can imagine, you can now solve, which hasn't been that case for a long time. So now we're in a position where people who aren't particularly sort of heavy-duty software engineers can now create these solutions. So hopefully, that will be something you'll be doing by the time you leave here today. How many of you would you class yourselves as heavy-duty software engineers?
Sorry,
well, how many of you would class yourselves as heavy-duty software engineers? Or even light-duty ones? Part-timers, okay, that's cool, right. So let's go back to the let's talk about the dinosaurs for a minute. Let's show you some stuff right here. Oops. Right. Yes, I was going to. Yeah. So I've got a home energy monitoring system that I built 12 years ago. So it was one before we had Raspberry Pis and things. Any chance of putting these lights? Or was it all or nothing? Or can you all see that?
Yeah.
So we can do a lot of stuff on the screen shortly, so we can make the contrast better. Yeah. Well, let's finish with that. So I've been sending live data to the internet for what my power consumption of my house is. So this is the fridge, that's the shower, those two are the kettle, that one's the dishwasher, that double spike there. Each different appliance has its own unique profile. That's better. But my family weren't as into these graphs as I was. They're not quite as graph geeks like I am. So I built this ambient device. I'm really into ambient devices. This is what we term a glanceable display, or a 1-pixel display. There's a chap called David Rose from MIT Media Lab in Boston who talks about enchanted objects. And that's really what the Internet of Things is about, is adding enchantment to everyday objects. So he invented the orb a long time ago, when I was actually hanging out at MIT Media Lab, which is where I got the idea from. But one of the products that David Rose sells through ambient devices in Boston is an umbrella that has a little kind of plastic diamond thing on the end of it. and you put it in the umbrella rack by the door, and as you go up to work, if it's flashing red, you take it with you, because it's going to rain today. If not, you leave it behind. Simple as that. So the umbrella goes online, checks the weather forecast where you're going to work, and if it's going to rain in the next 12 hours, it flashes it, just says it's flashing until you pick it up and shake it, then it turns off. So that's adding enchantment to an everyday object, the umbrella. So with this ambient orb, I'm able to find out how much power my house is using. It glows green, amber or red, according to how much we're using. And last year, we did a project with Tech Future Classroom, which is the Quango of BIS, which is the Business Innovation and Skills Department of the government that deals with ICT skills for the government and for the UK. And this was a project using an energy monitor, a Raspberry Pi, NodeRED, and a ping pong ball. And this was a project where you buy this kit, and there's on the website Tech Future Classroom, there's a whole video tutorial and a shopping list, and we'll distribute the link later, but it's quite cool as a starter project. And you can get going really quickly if you're a teacher. It's all the instructions and the teacher's notes, and it's a very sort of low stress, easy way of getting into programming. And then the children can go in and change the thresholds at which the colour changes happen and stuff like that. So as they turn lamps and fans and TVs and things on in the classroom, the energy monitor shows different values of the number of watts, and then this shows green, amber or red, so they can associate different things being on with different energy uses. Now, in true Blue Peter fashion, here's one I made earlier. This is a prototype, so it's in a cardboard box. I'm waiting for some kind soul to 3D print me a case, or for some even kind soul to give me a 3D printer. Anyway, so the prototype is made of cardboard, and the idea was to get it just right, so it doesn't rattle at all, so it's very precisely engineered, in fact. And the multicoloured LED in there is extremely bright, so you need a diffuser, so hence the ping pong ball. And this is connected over Wi-Fi to my house, well, it's connected to the internet, and my house is publishing information to the internet about how much power we're using. So this is green at the moment, which means we're not using very much, less than 500 watts. But I can spice things up a little bit. Oh, obligingly it's gone blue, which means it's just lost the connection. Okay. Hopefully that'll go green again in a minute. I can do what I was going to do. I was going to turn my kettle on remotely and make it go red, but we'll have to wait for that stunt. Okay, so the thing that makes this stuff work on the Raspberry Pi is some software called NodeRED. And what I'm going to do is show you a very basic introduction to what it is, how to use it, how to get some really easy stuff going. And then we'll do things like making LEDs flash and making some bigger things flash. And hopefully that will inspire you to at least get a flashing LED going. And then perhaps we can link it to a temperature sensor or query some online web services or whatever you want to do. We're all here to help. Some of my team here, Dom at the back, Ross at the back, and Andrew back, and Lucy, we're all here to help. Okay, so we'll be wandering around. Is there any chance we could do this, or how do you do that? So why doesn't this work? That's the kind of problems we love solving. So I'm really sad that this doesn't be connected. I'll suggest the rest of this will work. But, so let's look at some NodeRED first of all. So NodeRED is a software thing, a way of programming. Into window, and it lives. The bit that runs the program lives on a computer somewhere. Now, in this case, the program where the program runs is on this laptop. It may well be that it's on the Raspberry Pi. So we run a thing called the actual application called NodeRED on the Raspberry Pi, or it might be running on a server in the cloud somewhere on the internet. In which case, when you've written your program and what's called deployed it, so we've kind of set it running, it goes somewhere else to run. But the user interface, the place where you do your programming, is here on your laptop. So this is the user interface to NodeRED, but this isn't where the program runs. So although the user interface is on my laptop here, the actual program itself might be running on my Raspberry Pi or in the cloud or somewhere else. But on this particular occasion, just now, both the NodeRED program and the user interface are on my laptop. Okay, so everything's going to be happening locally. NodeRED runs on a programming language called Node.js, or programming system called Node.js, which uses a language called JavaScript. If any of you use JavaScript in web pages, you'll find the programming bit of NodeRED, which you need to do some programming, quite often you don't, quite easy, it's all quite familiar stuff. But I'll show you some simple examples of that. And the power of NodeRED is that when you want to connect things to the internet, or get data from somewhere, do something with it, and send it somewhere else, you don't have to do a whole lot of programming to do like an HTTP web request, or connect using a messaging system called MQTT to the internet to go and get some data, or send messages to the low-level input-output pins of a Raspberry Pi to turn an LED on or something. That normally involves going and finding some libraries from somewhere, or even writing a whole lot of low-level code before you even get round to writing the thing you want to do, the bit that says, let's find out when the buses are coming, or let's find out where the ferries are in order to make them tweet. So that's the fun bit that you want to do, but you've also got to do this kind of underlying gawpy stuff to get the data from somewhere and send it somewhere else. What NodeRED's done is they've encapsulated all the things you're likely to want to do for inputs, outputs, and a whole load of data transformations into these things called nodes. So the hard bit's been done for you. So all you have to do is the fun bit, which is really good. So let's do the simplest thing that we always do with programming, which is hello world. Now first of all, I'll just explain the layout a bit. So this is the canvas, this is where we do our programming. Over on the right hand side we've got the info bar, which tells you about each of these nodes. If we want to know what the HTTP node does, it tells you some information over there. So if there's anything kind of, anything you need to know about exactly how to use it. If it's not completely obvious from the node itself, there's information there to help you. Then there's the debug panel, which is really, really useful. You know how you put printfs in print statements in your programs to print out intermediate things to say how it's doing. The debug bar is there to give you information about what's happening, so it helps you, first of all, develop your program step by step, and then if it's not quite doing what you expect it to do, it shows you what it actually is doing in order to work out what went wrong and how to fix it. Down here are all the nodes in the palette. This is the palette down the side, so we've got input nodes, that's getting data from somewhere. Then we've got output nodes, which is sending data to somewhere else. And we've got all these function nodes. Now, some of these do really useful, they all do really useful things. Some of them do more useful things than others. So delay node, for example, if we wanted to say flash an LED red and then wait for 5 seconds and make it go green, or make a green one come on, you could use a delay node. If you want to do an if then else, so switch on a value, so if the values, say the wattage is less than 500 watts, then go out one way and turn a green LED on. If it's greater than 500 but less than 1,000, go out another way and turn an amber light on, and if it's greater than 1,000, we'll go this way and turn a red light on. So you can do it using the switch node. And there's a whole load of other things which are just really useful. There's a random node, which is one we actually use a lot in the dinosaur program, because we don't want the dinosaurs to be completely deterministic. They don't want them to always do the same thing. We want them to kind of throw a die and go, right, if it's 1, we'll do this sequence, if it's 2, we'll do this sequence, and if it's 3 or more, we'll do that sequence. And one of the things that we programmed last time was we've got a little family of triceratopses. They're the ones with the spiky things on their back. There's a mother and 2 babies. And we had the mother doing a sort of semi-random set of things. So it would throw a die, pick a sequence of movements and roars and head shakes and tail wags and things, and then she transmitted her movement sequence to the children, who would just sit there watching her, and then like 5 seconds later they'd mimic mum, so they'd do the same sequence. Which looked really cool, but of course, as we all know, children don't always do exactly what mother tells them. So we had it flip a coin at the beginning to say, okay, shall I obey mum or not? And if the answer was no, he went off and did his own thing, but sometimes, and more often than not, it would actually mimic mum. So it looked like these children, these baby dinos, were learning from mother, which was amazing to watch. So when you all come down to Blackgang Chine on the Isle of Wight this summer, you'll come and see this stuff happening. You can also link through the server that NodeRED's running on to a whole load of other things, like you can link to Twitter, for example. So when I said that my dinosaur listens out for tweets about me, I wasn't kidding. The input node for the flow that's running on there, which I'll show you in a moment, uses a Twitter input node to look for tweets, and you can say listen out for @MDSC or a particular hashtag or whatever it is you want. And whenever a message comes in, you can then process it and then decide what to do as a basis of that. You can wait for an incoming email, you can send emails out, you can send tweets out, so if something happens then tweet about it, which we do quite a lot, so my house tweets about lots of things. And then we've got various other things variously useful for doing the kind of programming tasks that we're trying to do. So there's a whole load of things, and lots of things there which may or may not make sense. You can get information in from a serial port, so you can monitor the serial port on a Raspberry Pi, get data in from something like a GPS or some other thing that sends serial data and read it in through there without having to go and do low-level serial port programming. So it's really, really easy to get stuff in. Any questions so far? Everybody's suffering in silence for half an hour. Yes?
When I've written software that generates a random number, say using VB.NET for example, that random number was generated based on the system clock, and if you called it very quickly, and then it would just respond with the same number. Would you have the same problem with a Raspberry Pi? Does it generate a random number based on the clock?
So I can't remember how it's seeded.
Yes, sorry, that's the word I meant, seeded.
I knew it was.
Yeah.
I know what I meant to say.
That's okay.
Yeah, but I didn't know what that word was, so thank you.
Okay, so random numbers. So a random number generator, so it's very difficult to generate truly random numbers. You can do it from radioactive decay if you happen to have a radioactive source about your person. I actually don't. I was going to power cycle this to improve things. So what you normally do is, as you say, you normally pick a sort of random number, like how many milliseconds the computer's been turned on for, and then you use that as a starting point from which to generate random numbers. If you pick the same seed on two separate runs, it'll do exactly the same sequence of numbers. So if you did flip a coin, and the first time you did heads, 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 tails, and you use exactly the same seed the next time, heads, it'll do the same heads, 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 tails, which of course is not probably what you want, because if you want it to behave in a random way, you kind of hope it would do it differently each time. Now, using the system clock is normally quite a good idea, because if you start running a fraction of a different, a few milliseconds or microseconds later or earlier than you did the last time, then it'll be a different number, therefore it'll seem truly random. Now, the question is, can you interfere with the seed on this? I think the answer is no. Okay, so it does its best to get over that problem, and it probably hashes together something like the MAC address and the system time and the temperature of the core, or a whole bunch of other things which make it a nice random seed, and then it generates nice random numbers for you. So I shouldn't panic about that. And generating in quick succession won't be a problem either, because it keeps it only uses the system clock at the beginning, not supposed to be.
Yeah.
Any other questions?
Can you see the code for those items in there?
You can. It's all okay. They're all written in JavaScript, and they're all open source. Now, you can't do it by double-clicking on it, because that gives you the interface. But if you were to log into the computer that this is on, i.e. my laptop or your Raspberry Pi, and go into the NodeRED installation, there's a directory called node_modules, which is what the underlying libraries are for this, and you can see it all to your heart's content. It's all lovely. Some of them actually are binary, so the serial one, for example, actually accesses some binary code, or some C code that gets compiled when you install these. But with JavaScript and Node.js, there's a really nice library system, and you do NPM, which is Node Program Manager. I'm going to try to decode just NPM. And you just do NPM install something, let's say NodeRED node serial, and it'll go and get all that stuff and get it all installed for you. So most of the time, fortunately, we don't have to look at the underlying Gorpy stuff, but you're certainly most welcome to. All the code for NodeRED is out on GitHub. It's all open source. It was actually developed by IBM. Two guys down in our lab near Winchester, in a place called Hursley, developed this rapid event deployment tool, which is why it's called NodeRED, R-E-D, as a way of rapidly prototyping applications that they needed to write for their customer projects. And we thought this was great, it's got us going really quickly, but IBM couldn't really work out what to do with it internally. We couldn't turn it into a product, we only had limited use for it internally, so I and others argued that the best thing we could do was actually give it to the open source and let others develop some of these nodes that we weren't interested in doing, and to contribute to the code, move it forward, and make it become, hopefully, sort of the wiring tool for the Internet of Things. And I'm very pleased to say that's actually what's happened. We open sourced it about 18 months ago, and it's gone completely nuts. The two guys who invented it go completely blown away by this. Nick O'Leary and Dave Conway-Jones, if you ever stumble across them, very cool guys. So this is now completely open source. It's still, most of the development work is done by these guys in IBM, but we do accept contributions, bug fixes, new nodes from lots of other sources, and loads of people have written nodes. So for example, the Philips Hue bulb, which I haven't got one of, but somebody out there has got, somebody wrote an interface to it for NodeRED. There's a Philips, there's a Hue node that you can download for this now, and one for the Wemo, and loads of different things. Far more than I've actually got on here, because you have to go to the big repository and find the one you want. You go, I've got a Pi lighter, you know, the little thing with the LEDs on the Pi. You can download that node. Okay, so let's write our first program. So what we're going to do is hello world, and there's a really handy thing called an inject node. This has two functions. One is you can make it create a message whenever you click the button on it, so you can kind of use it to drive testing of your program. But it also can be, if you open it, double click it to open it, you can also make it create a message every 5 seconds, let's say. So you can use it for creating timed events. You can also use it a bit like the thing called cron, where you can say fire at a specific time. So if you want to do something at 1 o'clock every day of the week, or just on those days and not those days, you can set this up and it will automatically trigger at that time. So it's a very powerful time management system for your program. So we're just going to do it when we click it. So we'll just do no repeats, just when I click it. And we're going to have it send in a message. We're going to do a string, do hello, bam, bam. Okay, this will be our message. And then in order to send that somewhere, we'll use a debug node. So these are really useful. You can pepper your program with debug nodes to find out intermediate results. And you sort of just wired those things together there, just drag the wire from there. That's my program. So that's saying generate a message and then print it out. Job done. So when I deploy this, and you always have to deploy your changes when the red deploy button is shining, it goes grey when you've done it. Now when I click that, I get hello FabLab in my debug node. Okay, it's as easy as that. I think every one of you could easily do the Hello World program. Right, should we do something a bit more exciting? A bit more exciting. Right, let's okay, well, let's do some. I'll just show you the timer thing. So 5 seconds, create a message. So I'm going to deploy that. Just turn the Wi-Fi. So we get it every 5 seconds because it's generating a message, sending it down the wire, and anyone who's on the other end of the wire receives it, and that then prints it out. Right, let's do something a bit cooler. So my little orb thing, which obligingly wasn't working. I've got a little thing called a Blink gun, which you can buy off Amazon for about 20 quid. It's got a red, green, blue LED inside, you can glow in any combination, and it's plugged into USB. So there is a Blink node for NodeRED. So I told them to write it because I wanted one. And if we plug in our USB here, okay. So now let's write a little program to drive that. So let's inject a string. It's a pick colour. Pink. Okay. Another colour. Blue. Cute. And then let's wire them up to a Blink node. Okay, deploy that. And I click that. Hopefully it goes pink. Yes. And I click that, it goes blue. Yeah. Okay, it's as easy as that. Now, if we've been doing something a bit more complicated, which we can now do, so we've proved that we can talk to the Blink. Let's do something a little bit more clever. Let's say, let's inject a. Let's start it off. Let's give it a couple of numbers. Let's see, 10. 600. So we're going to simulate energy use. So that's the number of watts our system's using. Then we'll use that switch node I talked about. We'll just wire those inputs to there. So in the switch node, we'll now say so every message has a thing called a payload. That's the content of the message. And we'll say if it's less than 500, then we'll go on pin 1 and add another pin. If it's less than 1,000, we'll go on pin 2, and otherwise it must be more than that, so we'll go on pin 3. So now our switch node's got 3 nodes, 3 outputs. So let's set this one, set the payload to green. So the change node lets you create a message, so you can just change the content of the message to green. And we'll do amber. And the third one is if it's more than 1,000, we'll go for red. Oops. Okay. Blink. We'll take our blink node, let's just detach it from here. Stick it over here. Wire it up to those, so whichever message gets generated, it goes to the blink. Deploy that. See? Right, so if we do the 10, it should go green. Oh, it went amber. Okay. So it's got a bug in our software there. Oh, okay, that one worked. So why did the 10 do that? Let's have a look.
So I think it matches all the rules.
Ah, thanks very much. Yeah, checking all the rules. Yeah.
I was about to say, I'd like to take your word for that, because I'm colourblind.
Ah, thank you so much. Yep. Please take our word for it for now. Hey, thank you very much. Green means low, amber is in the middle, and red means at the top. We should print that out as well, shouldn't we, for your benefit? So let's do that. Okay, so print that. Also wire the outputs to there. Here the thing, deploy it. That one tells you it's green, and then it tells you it's amber. You know, you can do. Oh, hello FabLab as well. So far so good? Cool, okay.
How do you kill those applications? Because you've still got FabLab running.
Yeah, so you, best thing is to disconnect it.
Just
Yeah, and then deploy. So the source of the trouble, i.e. the thing's generating a message every 5 seconds, stops. Or change that back to none, so that it stops it firing and deploy.
So how do you identify the port that is connected to the Blink?
So the Blink node
Yeah.
knows it's going to be a USB device,
So
so
you
it
have,
scans all the USB ports. And goes, is there a Blink here anywhere? It goes, ah yes, there is one here. Cool, okay, and that goes
what
top
if
for that.
there are more than one?
It only picks the first one.
How many outputs can you have? So you've wired that green to broadcast, and
Yeah.
Is there any limit to the number of outputs that thing can trigger?
No, there isn't, no, although it gets a bit messy. So what we normally do, and I did this just for grins, is it's actually easier to put a node in the middle, just an empty node that does nothing, like a sort of null node.
Right.
Wire them to there, and hang as many things as you like off the back end of it. That requires some forethought, which I don't always have. Let me show you what this node does. This is the function node. This is where the actual programming happens. If you want to do some actual programming, which I'm sure you're all itching to do, you can use the function node. So that its usual use is to transform a message from one format to another. So if we have a message, actually let's nick that hello FabLab message from up there. Oops. You can copy and paste nodes just so you kind of expect, which is quite handy for if you want to move some of them around, you can sort of pick them up and move them around. You can make your flow look nice and tidy. If we then,
Is it well documented?
quite well documented, yeah. It's fairly intuitive, I have to say. With the information in the info panel, it tells you what the change node can do. And starting with simple stuff and kind of gradually getting more complicated, you normally sort of work your way into it. So So this function node in the middle lets you transform a message. So at the moment we've got hello Fab Lab, so let's clear that. Okay, and when we click hello Fab Lab, we get hello Fab Lab, okay, as we expected. Because at the moment this is doing nothing, it's just a pass through. And this is, when I double clicked on it, this is now a JavaScript function. Okay, so you can write in here any JavaScript to do anything you like. The input, the thing that comes into the node, comes in as a variable called message, MSG. And it has two parts. Message.payload is the actual content of the message, so that green, red, amber, or the hello Fab Lab string is in the payload. So if we want to refer to message, that string, we refer to message.payload. The other part of it is called the topic, which is used by quite a lot of functions as a sort of bit of metadata to tell you what the message is about. And we'll see that more when we come to some wild messaging stuff in a minute. But so message.topic and message.payload are the two bits you normally mess around with. So if we, for example, wanted to change the payload, let's say message.payload equals, we'll put stars around it, okay, we'll augment our message. This is just normal JavaScript. So the new message.payload becomes the old message.payload with stars around it. Okay? And then we return message, which means we pass it to the output node on the right hand side. So now that little blue dot means we've changed this node but we haven't deployed it yet, and indeed the deploy button's gone red. So when we deploy this, and we click our inject node, we get hello Fab Lab with stars around it, as we expected. Okay? So that's a very simple way. So if a tweet comes in, for example, you might want to check it for certain words. You can do matching in it and only pass it on if it matches certain criteria. Anything you like, really. So if there isn't a node here that does what you want, and quite often there are things here using the delay node, the trigger node, the switch node, the change node, the range node, which actually do most simple things. But eventually it'll come to the point where you go, there isn't a node to do that. So that's when you write some code, okay? And that's in there. But it is fairly simple. It is in JavaScript, and you don't normally need to call any particularly complicated things in there. But you can if you want. You can write really complicated. Somebody's written an FFT for a transform algorithm that runs inside one of those. So you put some data in, FFTs it, and out comes the nice frequency domain result. Okay, I'm not here to teach you JavaScript, okay? So if you have something that you think you can't solve using these things and you don't know how to do JavaScript, stick your hand up and we'll come and help you. Interestingly, the very first Black Gang Chime workshop, there wasn't a random node then. So when we wanted to create, so we said, oh, we want to toss a coin or roll the dice. And so I quickly wrote about 3 lines of JavaScript in a function node which says, roll the dice, creates an integer between 1 and 6, and then everybody copied and pasted that around their Raspberry Pis, and everybody used that. Because we realised that a random node was such a useful thing, we then, the next week, created one so it's part of the palette, so you don't need to write a JavaScript function to create a random number. We've done that for you.
Andy, quick
Yes.
question.
Yep.
The function that you wrote to surrounded stars,
Yep.
give that a name, presumably stars, and
Yep.
that will appear in the box, will it?
Yep.
Okay. Right.
Okay.
And you can have as many different functions as...
Oh yeah, absolutely, yeah. So another one down here called stripes.
Second question, the output of this is JavaScript. Is that fairly universal? So you can have a small device somewhere, and all you need is like a JavaScript interpreter
Yeah,
on
so
that device.
Yeah, so Node.js is the JavaScript interpreter. So the JavaScript that runs in your browser is on the client side. Somebody thought a while ago it would be really cool if JavaScript would run server side. So they created this Node.js, which is a bit like as much of a browser as you need without the visual bit to run the JavaScript bit, the JavaScript engine. And they've made that as scrunched down as they can, so it runs on things like Raspberry Pis, BeagleBones, but it doesn't run on things like Arduino, so they haven't quite got it down to the Arduino level. Well, actually, they're a long way off yet. It's quite a big heavy thing, but it's still easily small enough to run on a Raspberry Pi.
Right, and is it fairly universal? If you've got a JavaScript interpreter for BeagleBone and one for Pi, the code that this generates will do more or less the same thing on
Yes.
each device.
Yep.
So it's device independent.
It's device independent unless you start playing with the hardware. Then everything changes. Because then how you access the GPIO pins and how you access the serial
okay, it
ports
needs a
is
hardware
different.
abstraction
Yeah,
layer.
yeah.
Okay.
When you copy one of those function nodes, I presume then you change the function in the original one, the copy doesn't change?
Correct.
Is there any way to sort of say, I want the function which I'm going to use 10 times? And
Yeah, there is. Well, so one way is if you. I see what you're saying. So if you write it, and then you
So let's
copy
say-
it 10 times, and you change the first one because there's a bug in it, you're then going to go change all the other ones.
Yeah.
Yeah. So there is a thing called subflows, and that is the ability to take. Let me show you. Subflows, create a subflow. Then have an input node. Oops, right. Input node. A node that does something. I don't know, that's put the thingy bob around it. Okay. And then return that. Some chevrons. And then we'll take that to an output node. Fire it up. Right. Now, it should be on here. Let's give it a name. A name. Chevroner. Okay, so I've now created a Chevroner node. So now if I want to write another program, chevron my message, pull an instance of that down to here, wire it in, so when we deploy that and do that, get chevrons around it. Now, and if we did 10 copies of that, whatever, but if we then go change that thing, so it does exclamation marks, now change the subflow itself, so all instance of it will now pick that up. Oops, off my syntax error. Too many quotes. Okay, and then we do that.
You can move the two codes.
Sorry?
Just one code.
Oh, thank you. Yeah.
Now you still have to.
and then
You've got just after the pass, you've got a spare.
Ah, thank you. Ah, right. Well spotted. Okay. Debugging on stage. Okay, now I've got quotes around it, and every copy of that would have also changed. So if we had another copy of it, let's do that, shall we? Let's do click copy paste, another instance, and do pi, like that. So now this one, it's time for pi, change the flow, put the chevrons back in. Okay, I've got my quotes this time, here we go, deploy that, and hopefully both of these will have picked up. Oh, didn't deploy it, sorry. There we go. Okay, so that is quite a useful mechanism. That's quite a new feature in NodeRED, so not many of us are using that yet, but it's really, really good. Just occasionally it's actually the thing to use. So far so good?
And presumably if you followed your chevroner with the stars function, it would put them outside
Ooh, yeah.
the chevrons, would it? So you
Yeah.
can change the functions together.
Yeah, absolutely. Let's do it. I think I deleted the stars. I didn't like the stars one, so let's make a new one. Okay. Okay. Wire that up to there. Nice bit of space for it to work. Okay. And this is really nice. It means you break down your program into meaningful chunks. So if your problem was, right, we need to put chevrons around this, then we need to put stars around it, then you do the chevron and then the star.
Yeah.
So quite often when you're thinking of the sequence of things you need to do to a message, you can break it down into Seymour Papert coined bites, mind-sized chunks, so you get your head around each of those and then close it down and move on to the next one.
You can also test those in isolation
Yeah,
to make
right.
sure that it works.
Yeah, exactly, yeah.
And then
Yeah.
work on those.
Yeah. And you can create a library of these nodes. So there's a, up in here, in this little window here, this little thing, there's you can export to library, which will then do 50 file save as, and you can save it into a library. You can then do import from library. And here's one I made earlier. Now you can also export to clipboard, and this is really handy if you want to give somebody else your code. So what you can do is you can pick up, if you've done a really handy node, say we've done my stars node, and I want to give it to Lucy, let's say, you export to clipboard, pick that up with copy, close, and I can email it to her, or instant message it to her, or tweet it to her if it's less than 140 characters, whatever, and she can just do, take that same, go to her NodeRED, do copy paste on the import box, and then that node appears. And there is a library called flows.nodered.org where a whole lot of people contributed useful flows to do useful things like checking the weather forecast or making these blinky things go, or a whole bunch of quite useful things which are just contributed, and you just copy and paste them and then import them into your flow, and it's like borrowing somebody else's program. Very handy. Yes?
Do we use HTTP addresses for things that is outside the
Yeah.
example here?
Yeah, so I'm not
Any
actually
example of this one?
yeah, online first. Yeah, good point. let's do some external stuff. What was it? Outline guest.
Yes.
That's very main though. What was it?
Guest.
Alright?
Yeah.
I just see it. Right. So let me just find a friendly web service I think I know exists.
I think we might be overpowering the Wi-Fi actually.
Ah,
If anyone's got Wi-Fi on and doesn't need it at the moment, can you switch on?
yes, I'm connecting. Do it through my Wi-Fi. Wi-Fi. Oh, cool. Okay, that'll work. Stymied by the internet. Oh, there we go. Okay, so I've got a web service that returns your IP address. Okay, so let's write a NodeRED program to go and get our IP address. So we'll have an inject node to start it off. You use an HTTP request node to go and get the thing. We're going to do a GET request on Okay, and then we'll just display what we get on a debug node. Deploy that, click, see It says requesting, it's in operation. The Wi-Fi is going to be up for it. There's some doubt.
So what did there, how errors are handled?
And what?
What happens if it fails?
Okay, so you generally get output in the debug tab.
Saying
It's usually quite helpful, so things like syntax errors you saw get flagged with red. If this never completes, oh there we go. Okay, so it's completed, and that was what the web service returned. Okay, so that could have been a big JSON object with the weather forecast in it, or whatever it was, which you can then put into a function node to split it apart and pull out the bits you want, and then say it's going to rain in half an hour. Like that.
So how could you, for example, refer to the alarm in your house? What sort of address you give?
Okay, so things in my house use a messaging system called MQTT, which is not an HTTP.
Yeah.
I'll show you in a minute. And each lamp or each thing in my house has its own topic, which is the address in the MQTT system. And I can publish a message, which I'll show you how to do in a minute, to my house to make something happen.
So it's not HTTP?
No, it's not.
Okay.
But if it was HTTP, then I'd put the address into here, so to be.
Yeah, this is what I thought at the beginning.
Yeah.
Okay.
Okay. So everybody happy with where we are so far? I'm going to go one more level down into this MQTT messaging stuff, because it's really cool and really useful. I invented it. Not putting it away. Okay, so there's a way of sending messages from things, devices, switches, buttons, different sensors out in the world, to other computer systems, and it's called MQTT. It was deliberately designed 17 years ago to be really, really easy to implement on little devices and really easy to send data to lots of different places that wanted it. And the way it does this is using a model called publish and subscribe. So things that produce data are called publishers, so they publish data out. Think of it like a magazine publisher, somebody who writes the magazine, writes the copy and sends it to a thing in the middle, which in the magazine case will be a distribution warehouse. So you get lots of copies of this magazine and you send it out to all the subscribers of that magazine. So if you're subscribed to Golf Weekly, then everyone who's subscribed to Golf Weekly gets a copy of it whenever Golf Weekly comes out, is published. If it's Snow Maniacs, which is in the magazine, then maybe these two people subscribe to it, so only those two people get a copy of Snow Maniacs when Snow Maniacs gets published. So this thing in the broker, this kind of clearinghouse, works out who to send the copies to. The publisher, the person who creates the data, doesn't need to worry about whether it's 0, 1, 1 million people listening to that data. They just send one copy of the data to this broker in the middle, and then the broker is responsible for sending copies out to all the interested parties. Okay? We call that a one-to-many distribution pattern, which is really handy for things, because normally if they're hanging on the end of a bit of wet string, like a cell phone link or a satellite comms link, they don't want to send 1,000 copies of the same message out, one to you, one to you, one to you, one to you. They just want to send one copy of the message across the expensive network, and then let somebody else in the internet send out lots of copies to all the interested parties. And moreover, if more people come along, say another 1,000 people come along, I don't have to go back and reprogram all my devices to say, right, can you also send it to these 1,000 people as well, please, and manage the distribution list, because these things typically, are out in the middle of nowhere, nailed to a post, powered off batteries, and you really don't want to go and reprogram them unless you really have to. Whereas the broker can very dynamically respond to new subscribers who come in and say, oh, I'm really interested in this piece of data, please. Okay, so that's the basis of this MQTT messaging system. And we use it all the time for sending data between Pis and sensors and devices and LEDs and all kinds of things. So I'll give you a really simple example of sending a message on MQTT and receiving it as a subscriber, so we can see how it works. So there is conveniently an MQTT node, it's the same, and it needs to know where the broker is, this thing in the middle that we are going to send to. And there is one running on my laptop here, of course. Let me just check there is actually. Yep. So we have a broker on localhost. And the topic, let's call it a lab topic, okay, in capitals, for sake of argument. So we're going to send a message. We'll put a topic in there, then we sort of send it on there. Look, deploy that, send it. See it says connected, that means it's connected to the broker that we specified, the one on localhost, and we've now published the message. But nobody received it because nobody was listening. But I didn't know that because I'm just a publisher. I'm setting it out. So I'm blindly publishing it, but no one's listening. If we now write a subscriber, let's write a subscriber, there, which connects to the same place, localhost, and subscribes to the same topic, and anything that arrives on that topic will display. Turn on the debug node, and then when I deploy that, see that one's connected to the broker as well. So although these are on the same screen, this one could be a computer somewhere in the world, that could be a computer somewhere in the world, they just happen to be on the same screen at the moment of this demo. If I then publish to the broker, it arrives on this one and appears there and prints out. So that's handy. Now, that wasn't particularly impressive because it's all happening in the same environment. Let me just create another MQTT subscriber. This one I made earlier. Oomph. So this is a little MQTT client that somebody wrote a long time ago. And we connect to the broker. And if I publish a message on our lab topic, appears over there because the subscriber said anything gets published to lab gets sent to that debug node. So it wasn't this one publishing, that one still publishes hello everyone, but he got it from this other publisher. And the broker said, oh, someone's published on that topic, I'll send a copy to any subscriber, which was that one. If we subscribe this client to the lab topic, and then it's there on the top, and I publish my hello everyone, not only does it appear in that one, it appears in this one as well, because there are now 2 subscribers to that message. But I didn't have to go and change my publisher, it still publishes that one message, and then now both these people have got it. So this is a great way of distributing data from one thing to another. Remember I talked about the baby triceratopses listening to the mother? Well, the mother was publishing her sequence of moves, and the 2 children were both subscribing to it. If there had been 3, 4, 5 children, they'd have also subscribed to it, and the mother wouldn't have known. She was still publishing the one message out saying, this is what I'm going to do. And all the children subscribed to it, received the message, and then delayed 5 seconds, flipped a coin to see if they were going to obey or not, and then ran that sequence of operations. And that was how the family of triceratopses came to life. Okay, any questions about MQTT? I'm sure there'll be lots more when you actually come to start using it, but it really is that simple. You just publish a message and then you subscribe to it. If you're connected to the internet, there are brokers out on the internet you can use to, so that, for example, everyone in this room could be subscribed to it. We had a thing where, at the last Black Gang trying thing, where all the people who had a dinosaur subscribed to the same topic. There were quite a few, yeah. By the end of it, yeah.
Your daughter's responsible for an awful lot of sales to Macklin.
Yeah, indeed, yeah. But some people just had a little program which played a raw MP3 file. And what we did was we said subscribe to the raw topic, ROAR, which whenever you receive a message on this topic, make your dinosaur roar in some way. So these ones go, Rrr! And some of them played the MP3 file, some of them just flashed a light. And at the end of it, I could send a message from my phone saying roar, and then about 10 different things in the room would light up or flash or roar, including the real dinosaur. Quite amazing, because they'd all subscribed to that same topic, and I didn't know how each of them had implemented the roaring function, but they just received the message and implemented it in their own way. Okay? Right. The Raspberry Pis. We've got 20 Raspberry Pis. And there's about 20 of you. It'd be great if you worked in pairs, that would be even better. So there's more than 20 of you, in fact about 30 of you. remember I talked about that schools project we did with the Raspberry Pi and the ping pong ball? As part of that, we developed the SD card image, the operating system image for the Raspberry Pi, that does everything the teachers needed it to do, to just download that image onto a Raspberry Pi SD card, plug it in, and then it would start running. It would already have the NodeRED, the MQTT, the little flow in NodeRED that took the data from the serial port of the current cost, did the low, medium, high, and then made the LED go green, amber, or red. That was already on the card. We found this is a really, really useful way of getting people up and running with Pis and NodeRED. So I've kind of continued to evolve that SD card image, and it's now available for download. And it has NodeRED, MQTT, and most importantly, all the nodes that are special to the Raspberry Pi. So things like controlling the GPIO pins, controlling some of the fancy things like the Pi face or the Pi lighter. It's got nodes for those specifically, and they're already on the palette, so you don't need to go installing new stuff on your Pi to make it do Pi things with NodeRED. It's all there, and everything's at the latest level. It's all really cool. So Andrew has put a whole load of those images onto SD cards, and so they'll be distributed with the Pis. The way it's set up to talk to them is because it's always, again, thinking of classrooms, it's always incredibly difficult to get onto the school's Wi-Fi network or on their Ethernet network. You have to get the sysadmin people involved, and they're always trolls. You've been to schools, you know what they're like. So what we did was we made it so that you can plug the Pi straight into your computer. So you get an Ethernet cable, plug the Ethernet cable into your laptop, plug the other end into the Raspberry Pi, and it forms a private network. And the Pi gives your computer an IP address, so then you can communicate with the Pi. So the Pi is on a fixed address called 10.0.0.1. Your laptop probably gets 10.0.0.2 because the first will be given out. And you can then contact your Pi by connecting to 10.0.0.1. So if mine's actually working, maybe, that, new window, I do 10.0.0.1 :1880, which is the address of the 1880 is the port that NodeRED runs on. That doesn't look like dodgy Wi-Fi cable all the time. Dodgy Ethernet cable, there we go. Get it. So you have to have the Ethernet plugged in when you power the Pi up, otherwise you think it's not connected to a network and therefore it doesn't start serving DHCP addresses, and it's very complicated. If your computer doesn't get an address, just reboot the Pi. For some reason, my computer has a problem with black leads. We saw this last time, didn't we?
What you may find is that some of those black leads are crossover cables.
Shouldn't matter.
It shouldn't do, but I've found I've found that on the odd occasion, if you connect a crossover cable from one device to another, where the NIC is capable of automatically flipping things over, then it does cause problems.
Okay, that's a good tip. Weird. Okay, I'm just going to reboot this. Well, that's felt rebooted, yes. Usually the best solution. Because then I can so then NodeRED is running on the Pi. It auto starts when the Pi boots up. And if you want to interface to it, i.e. write programs on it, you access 10.0.0.1 :1880, which talks to NodeRED running on the Pi. The first thing it does is serves up the user interface, which you then use to write the program, which includes all the nodes that the Pi knows about, so all things like the Pi lighter and the Pi face. And then when you hit deploy from your laptop, it sends the code, the program, across the Ethernet into the Raspberry Pi, which then turns it into the running NodeRED program, and it starts running there. You can then disconnect your laptop and close the window, unplug the Ethernet, do whatever you want, because the program is running on the Pi, it's not running in the window. Okay? So that's the difference between what's been happening with my laptop demo, because both the GUI and the server were running on my laptop, whereas with this we've separated the two. The GUI's on the laptop only for development purposes. When you deploy it, it's running on the Raspberry Pi, and it stays running there. So we talk about them running headless, so they can sit there running, flashing an LED, monitoring power, calling the internet, whatever they want to do, without your laptop being connected to them. And when you want to debug them, you can connect into them again, hit 1880, bring up the flows, edit them around a bit, look at the debug panels, redeploy it, and go away again.
Is there a non-GUI deployment mechanism?
No. You say no. Okay, obviously yes there is. Okay, so when this deploys, it sends a big blob of JSON from the browser into the Node.js server. If you were able to recreate that big blob of JSON and send it in, you can do a programmatic deploying. And we have been doing some very cool stuff with doing programmatic deployment of algorithms out to remote machines. One example is that in a classroom, we've got a teacher and then a whole lot of children with their Raspberry Pis all networked together. The teacher selects which experiment they're going to do today, say experiment number 4, the one about temperature, and then the Raspberry Pi on her desk sends out the right flows to all the Raspberry Pis on the children's desk, so that when they start doing the experiment, they measure the temperature, then send the data back to the teacher's one, which then starts compiling a graph of the cumulative results of what the class is doing. It's absolutely amazing to watch. I don't think this is going to connect to the screen. Well, I'm sure you'll have better luck than I do. I don't know why it's not connecting. Okay, so I think we're probably at the stage where we can distribute the Raspberry Pi. Is there any more questions? The first thing to do is get LEDs flashing and stuff like that, which would be quite handy if I could show you, I guess. Okay, folks. I've got my Pi connected to my laptop now, so just before you all get dug in, I can give you a quick demo of how to control the GPIO pins on the Raspberry Pi. Okay, so just turn the face of the screen a bit once again. I can show you how to do stuff. So you'll notice that I'm connected to 10.0.0.1:1880. So instead of it being the NodeRED on my laptop, it's the NodeRED on the Pi. Okay, so it's served up the user interface. And the reason we know that is there's a whole section in the palette called Raspberry Pi down the bottom with GPIO out, GPIO in, out, RPI mouse, which means you can plug a mouse into the serial port and use the clicker as a button. The LED board, which is that little multicoloured LED thingy that goes on top, the Pi umbrella, the Pi face, the Pi lighter. So if you've got any of those interface boards, you can use them directly. And let me just quickly show you how to control something using the GPIO pins. I've got one of these lovely traffic light indicators that Lucy has for sale when he wants one, or to borrow.
£5 for yours.
£5 when he wants to buy one. Red, amber, green LEDs. And they cool, talk to Lucy. And they plug onto the GPIO pins. And we'll plug them onto the. You have to be careful where you put them, fairly obviously, but you're in the right place. They're on GPIO pins 13, 19, and 26. Okay, so what we're going to do is we'll write a little program to control one of them. So we'll inject. We'll give ourselves a 0 and a 1. Okay, so you have to send it what state you want the pin to be. And then you connect to a Pi output node, and you go into that and you select the pin that you want. So pin 26 is one of them. So GPIO 26. Digital output. I don't know what colour it is yet, so I won't give it the name. But we deploy that. And when we click the 1 button, the green one comes on. Okay, so we'll pull up in green. Okay. And we'll replicate that again, and we'll pick one of the other pins, that one, this won't be green this time, so that one, and then that's deployed, green, so I didn't change it. Better. Oh, there, that's red. Okay, green one's still on from last time. We'll turn it on off. Right, that's red. So process elimination. Then make the third one. Okay, so that's the amber then. Oops. Destroy that. Turn the red one off. Then the amber one. Green. Okay, so we've got green, amber, and red. Ta-da! And that's manually controlled, but I could easily have it so that there was a random number generator. Pick the number from 1 to 3, select one of them, and then turn them off. Stuff. Click on a price on that stuff. We'll happily help you debug it. But traffic light simulator, so red, amber. There's too often that and green. Would be quite a nice little thing to try doing. Okay. And if you've got any other boards, like high face or high driller, then so there are nodes for those things as well. Okay.